Welcome, everyone. For those of you who do not know me, my name is Sara Bonella, and I am the Deputy Director of the European Center for Atomistic and Molecular Simulations, SECA, and I'm also a member of the Executive Committee of the Marvel National Center for Competence in Research, an initiative to study materials, both via experiments and numerical simulations funded by the National Swiss Science Foundation. SECAM and Marvel are two organizations devoted to the discovery and implementation of methods for research in different areas, from materials to biology. And what we try to do is to foster communication via events, via active research, via participation to collaborative research schemes. Now, one of the collaborations that SECAM and Marvel, who have the good fortune of actually having their headquarters here on the EPFL campus in Lausanne, Switzerland, is that we have initiated two series of lectures where we try to stretch a little bit the comfort zones of us lazy scientists and sort of force us to think beyond our usual themes. So today we're going to have a lecture, a rather exceptional actually, mini symposium organized on the theme of science and diplomacy. But we also have other activities that we run over the year. And here are a few things that are coming up your way, organized by Marvel. For example, on the 6th of March, we're going to host Alexander Chevchenko for a Marvel Distinguished Lecture, in which he will discuss how AI can help molecular simulations. Whereas on March 27, there will be a webinar co-hosted by SECAM and the Molecular Dynamics Database Initiative, a European project for storing trajectories generated via molecular simulation on the theme of this particular database called the MEMPROT database. And our speakers will be Charlotte Lynch and Philippe Stansfeld. Importantly, in Lausanne, at the end of August 2025, so this summer, we're going to host for the second time the biggest conference on electronic structure methods across the world, I would say. This is the Psyche conference in 2025. Please don't miss the opportunity to come and listen to lead experts in this area. You can find all necessary information on the psyche2025.net website. Let's come to what we're gathered here to do. This is a Marianne Manside conversation. So perhaps I should start by reminding those of you who don't know her about who Marianne Manside was. Marianne is one of those semi-mythical figures who contributed to the birth of a field, maybe without really being recognized for the importance of the contribution that they made. She was a woman who learned how to use computing machines and write code in the mid-50s, 1950s, who famously got a job at the Livermore National Lab in the United States by replying to a work advertisement posted in the local journal that said men wanted to work on computing machines. She went, she got the job, and then she proceeded to become an invaluable collaborator for Bernie Older, who, those of you who are familiar with the world of simulation will know, is one of the founding fathers of our field. Now, she wrote code with him, together with Tom Wainwright, for about 40 years. In all this time, Bernie has published hundreds of papers. Marianne is acknowledged in 15 of them and a co-author in only one. The years went by, she retired. Livermore started realizing the relevance of her role, and they created a special part of the lab to honor people who, like her, had contributed, but had become almost famous thanks to her work. So she's now in the almost famous Hall of Fame of Livermore. We had the good fortune to meet her and the privilege to host her as the first person in this lecture series here. She came, she told us about her life experience, and she was brilliant in communicating to all of us the joys and the rewards that she got from her work. An amazing 85 years old person who had much more energy than I will ever have. and who was really a pleasure to host. So, together with the director of CECAM and the director of Marvel, we decided that it would be appropriate to honor her, starting by naming this lecture series in her honor. So we are very, very proud that we did this 5 years ago. And, Marianne passed at the end of last summer. But what stayed with us is her enthusiasm for research and his broad curiosity, which is why the Marianne Mensaï conversations are conversations, not just lectures, and why they are dedicated to themes that are relevant for us as scientists and human beings, but are not, the latest developed algorithm or the most important piece of software that we will ever discover in our lives. So in that spirit, we decided that this was perhaps an appropriate time to think as human beings, citizens, and scientists to the topic of science and diplomacy. We have decided to address this from a different points of view: the use of science for diplomacy, how science can be an instrument for development through training, for example, how scientific institutions can bring together enemies to work towards a common scientific goal, and how science can play a role in continuing conversations when there are walls separating continents or countries due to politics or ideology. So what I am showing you now is the program that we have for today, but I don't really want to spend time describing it in detail. You can see it here and you will live it. Just remember that for every Marianne Mensaï conversation, we have a first part in which we invite our speakers to share with us their thoughts and experiences through short presentations, and a second part, which is less formal. I would say nothing is formal when CECAM and Marvel are involved, but even less formal than a standard presentation, in which we will engage in a conversation with our speakers. Now, I will have the honor to sort of try to moderate this conversation. People in the room are absolutely welcome to interject with their questions. People online, you can also participate in the conversation and in the discussion by typing your questions in the Zoom Q&A tool. My two able assistants here, the director of Marvel, Professor Nicola Marzari, and the director of CECAM, Professor Andrea Cavalli, will be very happy to relay your questions to us. So one tradition that we have, or at least I'd like to try to enforce here, is that in our view, the best way to get to know our speakers is through their presentations rather than through long introductions made by someone like me. I just want to say that we are truly honored and very, very grateful to the 4 people that have accepted to share this afternoon with us. For me, for the directors, this is, and for CECAM and Marvel in general, I would say this is a bit of a blind experiment. I mean, we have never tried to look into such a topical, interesting, and important issue. And so I believe that, we're really going to benefit a lot from the time that Roland Bouffonnet from the University of Geneva, Atish Dabolkar from ICTP Trieste, Jihan Kamel from the Sesame facility in Jordan, and Tasujiro Suzuki from the Nagasaki University in Japan are going to devote to us. So without further ado, I would like to invite our first speaker, Roland Bouffonnet from the University of Geneva, to take center stage here and to discuss with us computational diplomacy, understanding and analyzing international relations in the digital age.
All right, thank you very much, Sarah. See if it works. Wonderful. Well, thank you very much, Sarah. Thank you to the organizers. It's a real pleasure being here today, especially for me. I'm an EPFL alumni, and I started my scientific career here at EPFL almost 20 years ago, so it's good to be back. So I'm from the University of Geneva. I'm a professor in computer science and also at the Global Studies Institute. You will understand why in a minute. And I'm also the co-director of the SEED Lab, the Science and Diplomacy Lab, which is a joint initiative between the University of Geneva and ETH in Zurich. I'll present that. So today we'll talk about computational diplomacy. And if you're wondering what that is, well, that's actually the center point I will address in my talk. But this is the agenda. I have, tried to cover that in about 15 minutes. I'll first talk about science diplomacy. You probably realize that this conversation series is about science and diplomacy. And I'll try to pay a lot of attention to words and defining what science diplomacy is. My focus will be on science in diplomacy. This is what we do at the SEED Lab in Geneva and Zurich. And I'll give you some examples, concrete examples of scientific research in this area. Right, first, as a good professor, I have to start by giving you definitions. It's true that science diplomacy has been around since the end of World War II. It's been a fuzzy concept. And in 2010, the British Royal Society and the American Association for the Advancement of Science, they gathered and they felt that they had to put a proper framework for science diplomacy. So effectively, science diplomacy is diplomacy for science, science for diplomacy, science in diplomacy, and probably it doesn't help right at this point. You're probably still wondering what that is. But science diplomacy encompasses all of these three concepts. So let me go into the details. First, diplomacy for science. That's CERN, okay, in Geneva, and in France as well, not just Geneva. And it's ITER in Cadarache in France, where they study nuclear fusion. It's effectively different countries coming together to tackle, big problems. CICAM, I guess, falls, under this category as well, diplomacy for science, and also, of course, science at the core of it. This is item number one. Item number two is science for diplomacy, is using science, using scientific cooperation to improve international relations. And Jihan will talk about Sesame in Jordan, for instance. I guess this is a pretty good example of science for diplomacy. And the third item is the one that will be the topic of my talk. I will talk about science in diplomacy, where effectively we can use science as a way to better understand international relations, as a way to help decision makers. And the IPCC for climate change is a very good example of that. Let me move on to science in diplomacy, because that's really the core for what I want to do. It's like any science, it's evidence-based, right? We are going to perform experiments, we're going to make measurements, and from that, we hope to help decision makers. I mentioned the IPCC, that's exactly what they do. They are the one, telling us about the reality of climate change and predictions about how many degrees of, the temperature will rise in the coming years, by 2050, by 2100. That's a very good example of science in diplomacy. But it's also like, if you look at any kind of global challenges, climate change, global health, right? This is also science in diplomacy. Whether we're prepared for the next pandemic, right? That's an interesting debate. I think COVID-19 has taught us that we were not prepared, and I think the reality we're still not prepared. But there are a lot of scientists still working very hard in order to define how we can be better prepared for the next pandemic, whatever that is. And there is, promoting peace and security, but I will leave this to my colleague, Professor Tatsuchiro Suzuki, who is going to talk about that, in particular related to nuclear weapons and nuclear research. Okay, so I'm going to use one example to try to help you better understand science and diplomacy. And this is also something we work on in terms of climate diplomacy. So I don't think I need to tell all of you that the climate crisis is real. It's a major problem. It's global. It's accelerating. And if you listen to the UN Secretary General Guterres, what he said is that effectively we are losing the race, but it's a race we can win. The question is, okay, right, how can we win that race? There's a first element to that, and that element is, I guess, pretty obvious in the title of my slide here. It's science. Right? There's no doubt that we need science to win the race and to hopefully address climate change. It's effectively it's a necessary condition, but it's not sufficient. What else do we have? Well, we have individuals, us people, right? We have societies that are effectively reluctant to change. And that is a major problem. It's a real challenge. Decisions can be taken at the country level, and then the question is whether people will be able to accept it. And many of the decisions depend on, how we vote, depending how the country operates. And this is oftentimes, as a society, it's based on the concept of consensus, how we collectively decide whether we're going to implement this policy, whether we're going to have a new policy in terms of climate change. So there is a whole bunch of science that is dedicated to the study of consensus in society and consensus as a collective decision-making process. So effectively, maybe the equation for this will be some science plus science of consensus as a collective decision-making process that could bring hope in terms of addressing climate diplomacy. Let me tell you more about consensus. So if we look at climate change, there is here, as you can see on that diagram here, there is an overwhelming consensus among scientists that climate change is real, right? The human origins is confirmed. It's almost like 99 to 100% of all scientists agree on that. And I think in this room, if we try to have a poll, we'll have consensus on that. But that is not sufficient, because then if you turn to society, what you observe is that, beyond, the walls of EPFL and our campuses, people at large have a very different perspective. So this was in Switzerland, when it was about voting for policy in order to adapt the country to climate change. Well, it didn't go that well. And if you turn to the US, and I just want to say that this was in 2016, so I'm not even talking about 2025. Well, although there is complete consensus on the fact that climate change is real among scientists, well, there is a minority of Americans that perceive scientific consensus, to be effectively not the case. So there is a profound disagreement between the people and the scientists. And if I keep going to politics, how the political groups perceive that, obviously it's even worse. So this is part of the problem. How do we effectively use science as a way to address this gap between how the society perceives things and how scientists do it? All right. So let me move now to the core topic of my talk about computational diplomacy, but I'll start by saying a few words about our lab. So the SEED Lab, Science and Diplomacy Lab, is a joint initiative between the University of Geneva and the ETH in Zurich, where effectively we work on using all the latest scientific tools, simulations, modeling, AI, and so on, as a way to address topics related to international relations. We focus mostly on multilateral diplomacy, and I'll give you some concrete examples about that. You can see some of the people working in Geneva, and the team in Zurich is almost ready to go as well. But at that point, I just want to go back to Marianne Mansai. Sarah just introduced her, of course. And when I was invited for this talk, I was, I have to admit, I didn't know her. So, well, I did my due diligence, as a good student, I went online, tried to look for as much information as possible. And this is a picture of her when she last came to EPFL. And what really struck me is, how is this connected to what I'm going to talk about? I was a bit, trying to find ways to connect the dots between our work in computational diplomacy and, her work as a computer scientist in the 50s. And, after reading some of her quotes, it came to me, to written here, that the main element, the main connection is to that word of simulation. At that time, as you said, she worked with physicists that were performing Monte Carlo simulations. And simulation was effectively something new. Well, I'm from a different generation. Like for me, simulation is something very natural. And I'm pretty sure that for all of you in the audience, it's something that you do on a daily basis. But for her at that time, she was a computer scientist and she was like not really able to understand what a simulation is, whether it was useful. So we went from inventing simulation her time, and she was one of the pioneers that really helped that revolution towards simulation, to effectively performing all kinds of simulations at CCAM. We do that now for biological processes, for physics, for material science. And what we do at the SEED Lab is effectively pushing the boundaries of that, where we bring now this kind of way of doing things, performing simulations to another level by now turning to social systems. And we try to use, we'll tell you more, some of the tools that we're using, but that's the main idea, right? That kind of common denominator here is simulations. Okay, so what is, why should we do computational diplomacy? But what is the motivation here? Climate change is one example, dynamics is another. If you look at all the global challenges, there is not a single country that can address that problem. Right? Whether Switzerland decides to, adapt to climate change will not be sufficient, right? We are not isolated, and when it comes to climate change, each and every country will be affected and are part of the equation. So as a matter of fact, there is a very limited progress in terms of these issues. If you listen to, every year the COP meetings that are taking place, COP29 was in Baku this year, it's always the same, oh, it's very slow, we are slowly progressing, or sometimes we're even regressing. All of that is depressing, but we have the tools. We have the tools now to do things differently. Effectively, as I said, we can use, agent-based modeling, for instance. Right? We need now to take into account the human factor. The IPCC does a great job. They do a great job in terms of understanding climate modeling, in terms of predicting, the elements. There is something missing in those are the human factors. Whether, our economy will grow and whether we will adopt things, we just don't know how this is going to impact. There is not a complete model of the environment and the people, for instance. So agent-based modeling is one, network science is another one, AI, reinforcement learning, natural language processing, deep learning, data science, all of these are tools that have re-emerged and that we can use as a way to effectively study international relations. So computational diplomacy, is effectively sits, in my view, right, at the intersection between international relations, computational social science, and complexity science. You bring all of these together through like a true interdisciplinary approach, and you have the ability to address or inform some of these processes. Let me give you one example. This is excellent. I'm just on time. I like that. The example here is the analysis of the 2015 Paris Agreement on climate change. I know it seems far away, 10 years ago. Many things have changed since then, but this is not a work we have done at the Seed Lab. I just want to show you that we're not the only crazy ones, performing computational diplomacy. But this is a group of people across, Europe, China, and the US. And what they have been doing effectively is it's a publication in Science Advances where they have used big data analytics. They have looked at everything that has been generated by the Conference of the Parties, the COP meetings, which is organized by the UNFCCC, so the United Nations Framework Convention for Climate Change, right? So it's a pretty odd acronym. So those agencies publish everything they do about their negotiation processes and so on. Everything is online. So that group, what they did is they took all the data, analyzed everything, and then tried to form a model to understand what worked, what didn't work. And effectively, by using very, very well-known model of collective decision-making, Friedkin-Johnson models, at two different levels, they have been able to analyze and understand why the process has been so slow. Although consensus has been reached, right? The Paris agreements have been signed. So by having that information, there is the ability to effectively help, UNFCCC in terms of how they negotiate the processes. Right now, it's always based on full consensus among all the parties. I was in Baku this year, and I can tell you that it's depressing, right? To see effectively all these parties, arguing and talking and all of this being very slow. And you can argue that the actual process, the way they're trying to do things, is not helping the process. Maybe they could change that. Our role here is not to tell them what to do, but instead we work with UNFCCC to try to understand what works and whether, if there is gridlock, where gridlock is coming from. Here's another example, that would be my last example, and we can stop. This is something we just got published in the Lancet Planetary Health, which is a pretty prestigious journal, where effectively we have been analyzing all the resolutions from the World Health Assembly. So if you look at the World Health Organization in Geneva, they have a body, the assembly, that meets, and then they have resolutions. They have thousands of resolutions. So we analyze all the resolutions from 2048 till toward the end of 2023. And specifically, we looked at one particular problem, which is the interplay between environmental factors and global health. Whether environmental factors is, for instance, impacting antimicrobial resistance or pandemic, for instance. And what we found, from that analysis, which is pretty interesting, is that over the years, yes, the World Health Assembly has been paying more and more attention to environmental elements and environmental factors, but they tend to be completely disconnected from global health. So there is still here a silo between addressing the interplay between these two elements. It is well known from the past pandemic that there is a profound connection, and we need to understand that. So effectively, they are suffering from the same curse that we have when we try to do interdisciplinary research. We have effectively silos between different disciplines. The environment still remains something that belongs to people working on the environment, and health problems are separated. Now, I just want to conclude now by saying that effectively computational diplomacy is an emerging field of research that can be seen as an extension of computational social science applied to international relations. It is truly interdisciplinary, which makes it beautiful and challenging at the same time. Anybody doing any kind of interdisciplinary research knows that. And there is a lot of potential. Potential comes from how powerful the tools we have now in computer science in terms of AI, machine learning, natural language processing. So the hope is that as we surf the wave of AI and machine learning, we'll be able to better understand some of the issues that are facing the planet in terms of global health, in terms of climate change, for instance. And with that, I'd like to thank you for your attention.
Thank you very much, Roland, for this introduction to a fascinating field. I think we have time for a couple of questions. I would like you to ask questions on this topic. There will be questions to ask more, broad questions later. Time.
Okay, thanks a lot for the presentation, Jean-Pierre Hugo at EPFL. So you mentioned that the defining problem of the time is climate change. I would argue this is not the defining problem. The defining problem is digital trust. It's our ability to make use of information technology in such a way that people get properly informed and therefore make appropriate decisions when they elect people who are reasonable, right? So evidently now, because of what has happened in the US with the elections, things are going to be completely astray from the point of view of preventing, mitigating climate change. But the issue is not climate change, it's the misuse actually of online social networks by specific individuals that are able to manipulate millions of voters, right, with the outcome that we can see. The priority should be there. I'm surprised you have not mentioned this much.
That's a very good point. And maybe I'll modify my talk next time to include that. So I talked about the IPCC. Maybe you heard that there is a new panel called the IPIE. You heard about this? This is the International Panel on the Information Environment. This is a brand new, it's scientists around the world that are effectively looking at the information environment and how messy it is right now. It's a sensitive topic, so I don't want to be too, this is recorded as well. So I'm trying to be diplomatic and careful. But as a matter of fact, you're absolutely right. We are all manipulated in a way or another, and we have to be aware of that. The IPIE is working hard at that. I'm actually a member of the IPIE. Whether this is more critical than climate change, I guess this is up for debate. I have to agree with you that what is going on right now in terms of manipulating information and how politically this is bad in terms of collective decision making, I can simply agree with you. Trying to put on the same scale this versus climate change, I'm not sure.
My point is the point that it's going to be completely hopeless in terms of climate change as long as the current team isn't in the White House. This is explicit enough. You see what I mean? So that problem has to be fixed. Because as long as this is not fixed, the US is going to be over-consuming, over-producing CO2 and so on. It will be a terrible example for the rest of the world. So as long as this happens, as long as it is possible to have such kind of people in the White House, it means that the problem is not going to be totally addressed.
That's true. I mean, it's
That's it.
true. At the same time, if I may just answer to that, there is an emphasis on the US. There are many other things going in other countries where information is being manipulated in different way. And then you can also argue that even in countries like Switzerland, where we have a free press, there is also like, people are still reluctant to change as well. So I think there is social inertia, regardless or not of, of social media, but the social media are probably amplifying or not helping. That I agree. I think we had another question.
We have a question from the audience.
So it was very interesting, and somehow I had the feeling that you share with other disciplines like economics or finance the challenge of dealing with many players that can be irrational, exuberant, or anything. And so I wonder if you see the future for you of the field more in the, say, data analysis that is trying to understand what we have and why things happened, or more in the predictive, you mentioned, agent-based modeling in the predictive side.
All right, thank you very much for the question. It's actually both. We need the data analytics as a way to have a descriptive or empirical view of what is going on. And this is going to inform us about the questions we want to ask. But this is not sufficient. We need to go to the next step, which is modeling and having simulations. Because with that, then only we can understand the mechanisms, and only you can see, what are the unifying elements across different, problems, for instance, which can, help us in terms of forming, helping decision makers. So if we stay only at the descriptive level, I think this is going to be grossly ineffective, right? Being empirical and descriptive is really the first step. But this, it's like two sides of the same coin, I would say. And you need the modeling, you need the simulation element. That brings, prediction. I'm a bit cautious about predictive analysis, especially when it comes to social systems. And my colleague in the social sciences, when I say that, they say, where is your crystal ball? And they're probably right. But we all know as scientists that there is probably a limit in terms of, horizon in time with which we can predict. So, but in terms of having different models, having, knowing the sensitivity of different parameters, modeling those social systems is, probably key to solving the problem.
Yes, one more question, and then we'll move to the next speaker.
Thank you so much for your talk. It's quite related to the last point that you raised. And that's useful knowledge but I'm quite curious about, and for actual decision makers who are informed by this scientific knowledge that you're producing through your model and simulation, how perceptive are they to say this abstract representation of reality that they might be quite critical of how convincing the results are and what practically they could implement from the results?
Yeah, that is a great question, and that's also why for us being in Geneva is so important. We're very close to, the World Health Organization, the United Nations. We do work with them. I'm not going to lie and say that they're all very receptive. Some people express, actually, they are very reluctant or they are very skeptical about this, and I understand that, and I respect that. But it's up to us to show them that this is a real scientific process and it's rigorous at the same time. But there are a number of people that are convinced. And as I said, we work closely with the UNFCCC. They invited me to attend the COP meetings in order to see whether, we can be part of the game, in a sense, part of understanding those processes. So there is, I would say that it's a mixed bag. You do have a number of people that are interested in that. Now, this is at the multilateral level. Probably at some country level, I'm pretty sure that some countries are doing it without saying this. This would probably fall under, the umbrella of national intelligence. How do we vote? How can we manipulate the vote? This is something we have to be aware of, in a sense. The work we do at the University of Geneva and in Zurich is open to everyone. We try to look at only global problems, but some countries may use that, in particular with some particular companies that have access to tons of data. And I'm not going to name names.
So you will keep us guessing
Yeah.
more or less for a while. Thank you again for that. I would like to invite our second speaker for the day, Professor Atish Tobben, who is also the director of the Abdus Salam International Center for Physics in Trieste.
Okay, so good afternoon, everybody. It's a pleasure to be here. So I think I would say so. We have been in collaboration with SecCamp for a while, and it's a timely topic. I would say science, especially in sciences where there is a growing digital divide, and I will come to that point. And some of the questions that have been raised, I would say that ICTP, so ICTP is here in this very beautiful campus. So how do I show?
Let's see.
The point.
I think he's using mine.
I'm using yours.
Yeah.
Thank you.
Yeah, okay. So it's in this beautiful location on the Adriatic Sea. This is ICTP. And I would say that ICTP has been a successful model for science, promoting science around the world and achieving international cooperation and diplomacy through science. So I just want to tell you briefly a bit about the International Center for Theoretical Physics, even though now I'm a theoretical physicist, but we have a much broader portfolio now. It was founded in 1964 by the Physics Nobel laureate Abdus Salam. We're governed by a tripartite agreement between International Atomic Energy Agency, Italy, and UNESCO. And our successful delivery for the last 60 years rests on these three foundational principles: excellence at the frontiers of science, global inclusion for scientific resources, and international cooperation through science. And all of these have a bearing upon the science diplomacy part. So I would say that ICTP is a unique international research organization dedicated to this mission. That was Salam's vision, our founding director. And to overcome the barriers of gender, ethnicity, and more often, and more importantly sometimes, geography and economics. So really to bring science, make it available, and to everyone. Just to give you a few numbers, we have about 400 plus scientists at ICTP from almost 100 countries. It's a small center, but we welcome every year about 6,000 scientists for 60 very high-level conferences. Close to more than now, I would say, close to 200,000 scientists have visited ICTP over the years. 65% are from the developing countries, fully funded by ICTP. Who stay there for 2 weeks to 2 months or to 2 years, and about 32% have been women. And in terms of excellence, so this is inclusion. We have contributed to many important major breakthroughs in science, including, I was just discussing, CARP, Arinolo, you're familiar with, together with our sister institutes in Trieste, CISA, including a number of Nobel Prizes. We also have a big impact outside of our Trieste in Italy center. There are all over the world, several activities are organized by ICTP in collaboration with various people, various scientific institutions. So that's why ICTP really has a global impact for uniting the world for science. And now I will come to through science, which is the topic of. So science diplomacy through international cooperation, ICTP has been playing quite an important role in an indirect way. It's not like we are talking about science diplomacy in our cafe, but we have been a door opener for major science infrastructures because, as we know, science offers a common language, even if people are coming from diverse backgrounds. Newton's laws don't change. So we sort of understand each other, have the same basic understanding of certain phenomena. Just to give an example, I think you will hear more about it. This is a wonderful example. Sesame is a synchrotron light source in Jordan, funded by Israel, Iran, Palestine. I mean, it's It's an exceptional example of science diplomacy. Sounds like almost a news from the alternative universe if you look at what is happening. But ICTP has played a role in some of these key ideas got seeded in the environment in ICTP, where scientists from all over the world are meeting together. ICTP funded a major conference in Dahab, a seminal conference in 1996, uniting various countries to promote this idea, which looked like a pipe dream 20 years ago, but actually it has now been realized, and you'll hear more about it. Of course, several other organizations and many others have played a very important role. I'm not claiming credit for it completely. And I think ICTP continues to play a similar role. For example, there is a Southeastern European CEAST, which is for a Hadron Collider in Southeastern Europe, and also various synchrotron facilities around the world. ICTP has been one of the founding members of major international years, like the International Year of the Light. This year is the International Year of the Quantum, and ICTP was one of the driving forces behind it. So I would say this is kind of a diplomacy in action. We have 4 partner institutes around the world to do it globally, what we do at Trieste, in Rwanda, in Brazil, in Mexico, and in China. So what makes ICTP unique? I mean, in terms of science diplomacy, what are the elements that make it work? So first of all, we have an impressive track record of 60 years of excellence and inclusion at the highest echelons of science. But what additional advantage is that we are a UN organization with the corresponding political neutrality and convening power for multilateralism. And I would say that the need for such an international hub is even greater today than in the 60s, when there was a Cold War, to address global problems with global equity. And I would therefore see that an organization like ICTP has a major role to play. How much time do I have?
4 minutes.
4 minutes. So I will just briefly summarize my thinking, why I think ICTP remains relevant in the coming years. First of all, talking to policymakers or to public, there is greater need to emphasize the essential unity of pure and applied science. People think that quantum just falls from the sky, but you really need, you need to really understand quantum mechanics before you do quantum technology. Greater need to ensure equitable opportunities in the ongoing technological and scientific revolution, especially AI and machine learning and quantum computing, and greater need to ensure essential global participation in global challenges like climate change. I will very quickly run through them. Importance of fundamental science, I don't need to emphasize. There is a quote of Euclid to Emperor Ptolemy that there is no royal shortcut to geometry, and there is no royal shortcut to quantum technologies or to AI. You need in your country people who can understand quantum mechanics or basic statistics. And this is really actually going to be very, very important in the coming years, as we all understand. There are frontiers of fundamental science that really go from unification of forces to machine learning. And ICTP actually has core strength in all these fields that are listed there. Second is the future of computing and quantum science, particularly relevant for SecCam here. As we realize that in modern scientific method now, computation has become the third pillar, apart from theory and experiment. And there is a growing knowledge divide, almost an arms race, when it comes to modern algorithms and tools like GPU, AI, and quantum computing. So it's really an obligation for an organization like ICTP to find the means. And this is one of our challenges. And then one of the preconditions for meaningful participation in decision-making in climate is that everybody who is affected is involved. And for example, some of the important monsoon workshops, so the monsoon is a problem, the Navier-Stokes equation has the Himalayas as just a boundary condition. They don't care about whether China and India are at war with each other or they're friendly with each other. But the Chinese climate scientists and Pakistani and Indian climate scientists cannot meet in their own countries. And very often they come to ICTP, being a UN organization, And this is where the dialogue and the scientific diplomacy takes place. Just by offering an environment where people can meet in a neutral zone. And this is actually a very important role of ICTP. So I think of ICTP as a lighthouse for global science. This is actually where we are in Trieste, you see. Now, in this regard, we have launched a number of new initiatives, and I just want to very briefly tell you, which again has very much a strong bearing upon science diplomacy. So we started this idea of International Consortium for Scientific Computing. And the idea behind it is that ICTP's fundamental mission is open science. But it's evident that open science in the past, at the time of Salam, it meant open access to conferences and journals and meeting with people. But now open access to computational resources is even more important. Otherwise, you cannot actually do your physics. I mean, I'm a kind of a pencil and paper physicist, but more and more, the next generation is simply like a protein folding problem was solved using machine learning. So you cannot actually do advanced science if you don't have access to this. We need open codes, we need open weights, scientific computing, not for self-driving cars. So this is the idea behind this international consortium. Similarly, for future Earth, we regard it as our obligation. Again, it's the same problem that you might have a wonderful climate code, but somebody in Ghana needs to use that code and predict the rainfall in Ghana, because Ghana's economy actually depends primarily on a big dam, hydroelectricity. But if they don't have access to the codes, and if they are not part of the process, if there is no climate model that they are part of, they simply cannot be meaningful participants to the decision making. So with these two ideas, we have started this idea of, we have been working towards this, creating this International Science Alliance to bring together various parties together. SECAM is one of our partners. And the idea is that ICTP will help to bring the intellectual resources and tools available to the broader community and offer internationalization. We've had, for example, several arguments. This is with the Ministry of Brazil, but now we have global partnerships around the world. So slowly, this idea of an international consortium is catching speed with Brazil, with South Africa, with IBM, some of the corporations, with SECAM and Chineka, with Arab Funds, so for the Kuwait Foundation, Simons Foundation, and private donors. So this is the idea of the International Science Alliance, that we really create an equal partnership to address global problems together. And ICTP, being a world-class science center with a UN mandate, can play an important role in this difficult and important challenges and opportunities that we will be encountering in the coming years. This is what Stephen Hawking said about ICTP. Just to give you, there are many such testimonials about ICTP's impact, and I'll stop here.
Thank you very much. Partnership with ICTP is very important for SECAM as well, and we are, working together towards the provision of computing resources for developing countries, starting with a pilot in Africa. First call for that should be announced around mid-March, so stay tuned for more news on that. Questions from the audience or the people online? For the online participants, you can type your questions on the Q&A tool in the room, and someone will relay them to us. But let's start to see if there are questions in the room.
I guess sadly you are on the younger side, but the question is, have you seen a change during the years on how scientists from what we say, we call maybe incorrectly developing countries, but let's call them emergent economies, sort of, see themselves in the world scene?
Yeah, so I have to say, I come from India, and much like Salam, I really wanted to go back to, I did go back to India, because India today is very different from the Pakistan of 1960s. There are some really top institutions which are world-class by any standard. So I was not missing out on science when I went back. So after spending many years in the US, I went back to India. This is actually a very important question which having seen both sides, I feel that the model at the time of Salam was a little bit, let's say, patronizing. It was a one-way street. Now these communities, India, Brazil, I was recently in Brazil, there are very strong scientific communities. Many leaders in the field are in those countries. So the role of ICTP is not so much it's no longer, it really is equal partnership. And I think that's why I'm calling it an International Science Alliance. That it's an alliance and it's not ICTP giving the resources available. And I think it's positive because that way more resources are becoming available to ICTP. But at the same time, having said that, I've been in India and in Brazil, there is huge need for internationalization. I think still, and now China and the US, I mean, there could be difficulties for very top scientists to actually communicate with their colleagues. And this is where, as I said, the monsoon workshops is an example, but this is actually works across the board. So I feel that the differences between the scientific abilities of the so-called developing world and the developed world are diminishing, but the role for internationalization remains very important. In fact, even more important today than it was before.
Brett?
Thank you very much for the presentation, and me to Paul's question. When last year I was in Bangalore, I had exactly the impression that there is really a growing trend for science, particularly for computational science. The examples that you mentioned is mainly computational sciences, which are leading this evolution in India and Brazil, or is also for experimental science, for large research infrastructures like synchrotron, synchrotron.
Yeah, so for example, I visited the synchrotron in Brazil, so it's very impressive. If you have not been there,
No.
Sirius is it's a generation 4 machine, whereas as you know, the national facility Electra of Italy is generation 3. Even in the US, there was no generation 4. Maybe now they will get a generation 4 machine. It was really a very impressive facility. It cost about 600, more than €500 million. It was completely homegrown, totally world class. It's not LHC, but it's top of the line synchrotron facility in Brazil.
There is a leading role for computational science, or is everything is going parallel? This is your impression. But my experience was very limited. I got the impression that computational science is, for the time being, playing.
As you know, there is a bit of the hype. Also, there is a bit of a hype. There is a quantum hype, let's say. Also AI. So I think there is a kind of suddenly the policymakers are feeling that they need to do something. So India has suddenly launched a quantum mission with €500 million, and I don't know what will actually happen. But so I think it's partly because of that. But I would say that, like in my field in theoretical physics, Indian scientific community has been very strong, and some of the major breakthroughs have come from India. I was myself in India. So I would say not so in experimental physics, because it requires bigger infrastructures. But yeah.
Thank you very much. Thank you, Atif, for. Now I'd like to invite Dr. Mel, who is the principal investigator at the Sesame facility. We have heard bits and pieces about it already, but the whole story is truly fascinating. Thank you.
Well, good afternoon. Thanks to you, to Nicola, Andrea, for this, I would say, thoughtful invitation and to to hear more about the science and diplomacy or in diplomacy or for diplomacy things. I must admit that I'm a physicist. I'm not a science diplomat. I use my own expressions and my own experience working for this place for like 10 years. And even before, 10 years before also, I was just going there as just attending workshops or schools or users meetings. So I didn't put a title for my presentation because sometimes titles for these presentations seem to be like a slogan or cliche. But I just found this picture. Why do we only rest in peace and why don't we also live in peace? I think this sentence expresses a lot what's going on in our region, and what I'm going to give you in these minutes is just a flavor of the other side of the world. Maybe you don't see it frequently in the news, but I'll just tell you something bright that's going there despite all the horror that this region is living. So I'm going to speak about Sesame, which is a particle accelerator, is a synchrotron light source. And what we are doing there is that we are working with synchrotron radiation. This synchrotron radiation actually was observed 6,000 light years away, but it was also observed in the lab in 1947. And this kind of radiation allows us to see what we call it, we see the invisible. And with this, we are able to investigate matter with different applications, different domains, different levels. So we go for elements, atoms, and molecules. And the applications are really wide that span from basic and applied science like physics, biology, chemistry, cultural heritage, archaeology, material science, industry, and whatsoever you can find there. And it would be sometimes natural to think that regionally shared problems can best or only be solved through cross-border collaborations. And sometimes people think that it would be also easy if you are sharing same language, same history, same geography, but sometimes this is really not enough, as it's the case for the Middle East. Because there is a very important factor that commonly people are not aware of, because everybody thinks when you're talking about large-scale infrastructures, you're talking about budget, which sometimes, even if you have the budget, which again is not our case, you are still missing a very important factor that's called peace. And it's not strange to find hundreds of books and articles on peace in the Middle East. Everybody is asking what's going wrong with this region. Whenever peace will be available or presented there by any kind of agreements or treaties or whatever. And I would share with you some quick messages of this case. My father was a geography teacher, and I was raised seeing a lot of maps. So I think that it's quite easier way to express the information. So this is a map of the Middle East, actually. You can see it everywhere. And this is what I call it the theory. But since I'm an experimentalist and physicist, I go to the experiment. And this is somehow the real map of this region. So it's shaped by deeper international and national relationships. It's not only among countries in the region, it's also, you can find this kind of different experiments in the same country. And this is the reality. If you want to express this map into reality, if you want to publish a paper after going through an experiment, this is our region And here you see, I counted like 4 or 5 countries in the Middle East sharing these 6 photos. So what I'm going to tell you is that despite all this horror, despite all these figures and photos that we see every day, we are having something like this. We're having something called Sesame, which is the synchrotron light for experimental science and applications in the Middle East. It's located in Jordan, in Amman, that's like 35 kilometers northwest the capital. And Sesame has a very particular and unique story that started with a donation of an old German accelerator that was called BESSY-1. And these boxes that you see on this ship is BESSY-1 components. Those I call them Sesame in 2002. So these boxes were components coming from Hamburg to Jordan, Aqaba, to be the seed of the only synchrotron light source in the region. But of course, that was not enough because people knew that it will take them like 20 years, which already happened, to bring these boxes into an operational facility. So an extensive upgrade was mandatory. And this picture to the right is what we have right now, Sesame in 2005 and so far. Again, another map to bring you closer to why Sesame is considered a bright example or model for science diplomacy. Just look at the map and you get to know that it's an intergovernmental organization at the service of its members, but not only, it's open to the whole world. And these are the Sesame members. And without alphabetical order, because my brain is confused now, it's Jordan where it's hosted. And you have Palestine, Israel, and Iran. You have Turkey, Cyprus, and you have Egypt and Pakistan. And it's quite clear why this place is considered a model for science diplomacy in action, as we call it. As the war is going on, this place is still operational, and we're still receiving users from all over the world to do experiments. And we don't exaggerate sometimes when we say that this place is the only place on Earth after the United Nations where these people sit together on the same table without fighting. We have also observers, and they are quite a lot, those you see there on this slide. And observers for Sesame is not a political term, it's a term that categorizes these countries or institutions of the what kind of assistance they are helping this place with. So it's either collaboration or equipment, donations, training, providing expertise on all levels, scientific or technical. And I would say that it's a non-ending story. It started in the late 90s, as Abs was saying, and it's going on till the moment. I'll be more specific into this theme of the seminar, and saying that since we are modeled on CERN, everybody correlates Sesame and CERN a lot, and it's actually the same principle. However, we always say that for CERN, the war is over, but for Sesame, the war is not. So many people are thinking to bring these people together, like bringing all these governments and these parties in conflict or in war together through diplomacy. But for us, we're always skeptical in that region with this word. So political issues, diplomatic issues are bringing us a lot of skepticism because nothing happens. We can have a lot of agreements and treaties, but nothing happens. So we had to add a neutral term that would leave no space for any skepticism. And this is a slide that I always show in my presentations that show the science diplomacy in action. And it shows you simply what the members or observers can do together. So here in this slide, you see just one cell of the accelerator, and you have Spain, France, UK, Germany, Turkey, with Italy, Switzerland, and Israel, and Pakistan and Cyprus. So this is what we call science diplomacy in action, how these governments come together for once to do something useful. And for us, as we are also human beings, we are not only scientists or engineers. I like when you said this is informal conversation, we are scientists, but also human beings, yeah? We are not robots. We cannot go just to the lab and run an experiment and think that nothing is happening. But we learned quite well that put your emotions aside and think just of the task that you have to do. So for us, we only rely on this very simple equation, 1 + 1 = 2. We do not think further. There is no space for disagreements or conflicts inside Sesame because we only deal with scientific terms. And this is a collage that shows you what Sesame is actually till now, despite more than 1 year of a current war, ongoing war. I start with Abdul Salam because in the late 80s, he was the one who said that this region needs a facility like this. And we start now, we have to start now. And this now came after like more than 40 years maybe, yeah. And here you see, in this picture, you see the rectors, you see scientists, you see diplomats, users coming to perform experiments there. So it's quite open and I would say tolerant, unbiased environment. In this place, nationalities do not exist, religion does not exist, culture does not exist, only science that exists there. And I like this African proverb that says, if you want to walk fast, walk alone, but if you want to walk far, walk together. I think that this proverb applies a lot in our case. And in 2017, as a result of all this work and efforts and determination, persistence, patience, it was inaugurated in 2017. In 2018, it became the first associate of LEAPS, which is the League of European Accelerator-Based Photon Sources. In 2019, CISA became the world's first particle accelerator that is fully powered with renewable energy, and so far it's the only facility of this kind that is working with green energy. And this is just to take you inside. It's a 3rd generation light source. And these are some of our experiments, I would say, like the portfolio of our beam lines. We're working with a huge range of synchronous radiation, ranging from infrared to soft X-rays, hard X-rays, and we are also having an ambition to bring closer the African community, and we are having some efforts to establish an African beam line at Sesame. I'll tell you now why. With these experiments, we're also aligned with the science missions for sustainability, the science for peace and society, aligned with the Sustainable Development Goals. And not only science, Sesame also helps somehow to reverse the brain drain, which is a very problematic issue in our region where everybody wants to go abroad for a better education, a better life whatsoever. And equal opportunity is something that also makes a difference. It opens the door for so many women scientists to prove themselves without any issues, I would say. And I've been the only woman scientist for something like 9 years, and the last year we've got 3 more. So this place is somehow making a difference also in this regard. Our users community are from these countries you see listed here. And apart from the users coming from the Sesame members or the Sesame observers, we have also received a good record for African users. Those are also trying to go to this kind of research. I would end with another case that also requires a lot of attention as science diplomacy, because Africa is the only continent so far that lacks these kind of facilities. There's more than 50 synthetic light sources all over the world and none in Africa, where for the last 15 years or so, a lot of efforts are being done now to have the first African light source. I end with this. Some people think that we are quite, maybe we are optimistic more than necessary or hopeful more than necessary. Maybe we are not realistic, but we totally understand this message very well. We understand that science alone, experiments alone, cannot solve our political issues or security or economic, but we believe that using science diplomacy, as it has been the case for us for some years now, we are able at least to go outside the lab to help in solving issues for water, energy, food security, that again somehow are hidden factors. Those contribute sooner or later to our regional instability. And I thank you so much for your attention.
Thank you very much, Ilhan, for sharing your thoughts with us. The talk is open for questions.
They are shocked.
Let's start with Nicole.
I enjoyed this very much, and thanks a lot. So you mentioned the positive note that besides the United Nations Security Council or whatever the General Assembly, let's put it this way, this is the only place that puts together, a number of, let's say, representatives. Do you have the feeling that actually, in this world of sesame and of science, all the geopolitical tensions disappear, so they really reflect, especially when it's time to make strategic decisions on what to do next?
I would say so, because it's something that I saw it myself. I was the staff representative for 5 years, the last 5 years. So I saw it at the council level different times. We have our council is held twice a year. So I saw all these people sitting together without no issue that you can sense. They are totally normal. It's a totally normal meeting. There is something called closed session where only members join. But it was, all the conflicts, all the disagreements were really put aside. When it comes to a strategic decision for the use of this place, everybody works together. And I would give an example that we were very skeptical at the beginning of the war of 7th October. The next council to 7th October was in December. And we said, okay, we will never have Sesame anymore and no council anymore, but they held the council and they were there. And through this year as well. So the council is being held, these people meet together and some kilometers, away from this place, this picture of the war is going on. So it's really, I would say that as if it's a parallel universe for us. This thing is going on, but it didn't affect so far. On a practical note, some users were not able to come for experiments from different, or let's say specific countries. But rather than that, everything is fine. And I think now it should be also those who were not able to come before, I think now they are able to.
So Jihan, following up, has it always been like this, or has this been a process? Was this like this from the start, or has this been a process where different people have learned how to
It was a process. It was a process. I can give an example, but I'm quite, well, I wouldn't say nationalities now.
Don't say nationalities. no.
Yeah, I mean, I remember at the first users meeting I attended for Sasanawad in 2005. And there were some specific speakers from different or specific nationalities, and I saw it when a speaker was supposed to start a presentation, everybody goes out of the room. But after some years, people stayed, people asked questions and exchanged ideas. And the thing that we are hopeful to have soon is to have joint projects. It happened with some members of Sesame, their governments are at conflict, actually. So we have publications.
But the scientists collaborate.
But the scientists collaborate and publish together. However, I must admit that the last year may have changed something again, took us back somehow. Not everybody, of course, but I think we need to, I don't want to say that we need to restart, but we need to remind ourselves where we were, let's say, a couple of years ago, and let's not go back for 20 years ago. A couple of years ago was quite good for us. Yeah.
Thank you. Any more questions? But if not, thank you very much. Yeah. Our last speaker for the day, who is here wearing, I would say, a double identity as the director or as a leading member of the Research Center for the Abolition of Nuclear Weapons in Nagasaki, Japan, and as the chair of the executive committee of the Powers Conference.
Right.
Tatsuhiro Suzuki
Thank you.
will
Thank
tell
you.
us more about both things.
Thank you very much. Thank you for inviting me to this very interesting, timely seminar. Let me introduce myself first, a little bit more. My background is nuclear engineering. Engineers are not a physicist, right? And more practical, I would say.
Thank you.
Anyway, but I switched my background career to more policy studies after master's degree. So since then, I'm mostly working on this nexus between civilian nuclear energy and nuclear disarmament issues. Okay. All right. Today, I would like to discuss 4 topics. All of them are based on my personal experiences. So not necessarily the whole world, but I just based on my personal experience. First, I just want to say science and policy making. This is my favorite quote. Science without policy is science. You agree? But policy without science is gambling. So this is very important phrase that science can contribute to policy. So policy should be based on science. Another important quote, I like this. This is from Dr. Arie Weinberg, who developed a nuclear reactor in the United States, but he faced very serious social opposition in the United States. He published this article in 1972. It's called Trans Science, which means the question which can be asked of science, and yet which cannot be answered by science. This is sometimes very difficult for scientists to understand. And my colleagues, nuclear engineers, believe nuclear energy is the solution to the energy problem. But there are many social, technical, not technical, social, political issues that face nuclear power, particularly the nuclear-based issue, and also safety issues. Radiation, the safety of the radiation impact on the health issues, very, very difficult actually to explain to the public. But anyway, so trans science issue is another important lesson for me because I was a nuclear engineer, but I have to talk with many policymakers and general public who does understand science, but they say science is not everything. So this is true. Okay, let me tell you one difficult situation in Japan. Science Council of Japan is like a National Academy of Science in the United States. Has to be independent from the government. It was established right after World War II, reflecting the experience that the Japanese scientists contributed to the war games. And after that, they created Science of Council, saying they declared they would never do scientific studies for military purpose. And now this has been declared, this has been under threat. The government rejected the members of the nominees of the Science Council of Japan for the first time in history in Japan in 2020, and government never explained. Basically, those people, those nominees are against the militarization of science in Japan. And now the Japanese government is trying to separate the Science Council of Japan and putting supervisory council members who nominated by the government to supervise Science Council of Japan. So this is a press conference just last week, actually. 6 past presidents of the Science Council of Japan oppose such a government efforts. I think the science is very important to keep the independence from the government. Okay, plutonium issue. This is my favorite subject, actually. This is a chart showing that how nuclear fissile material will be produced. This is uranium, which should be enriched, but the plutonium has to be reprocessed. So enrichment and the reprocessing are key to make fissile material, which also the key facilities for the civilian nuclear energy. And this is the statistics that we assemble every year, how much highly enriched uranium and plutonium exists in the world. Do you know how many nuclear warheads exist in the world? Can you guess?
12,000.
Huh?
12,000.
12,000. Excellent. 12,000. Roughly 12,000. And but if we calculate the fissile materials based on Hiroshima and Nagasaki bomb type, now we have more than 112,000 bombs equivalent exists. That's terrifying, right? And but highly enriched uranium, 95% are military and is declining. But the plutonium, about 60% is civilian use. And that is increasing. That is the problem. Japan has the largest plutonium stockpile as a non-nuclear post state. That is my primary research subject. Anyway, and if you see this, the red one is 2021. This is from 2011 to 2021. This civilian use of plutonium has been increasing, and this military surplus is declining. And this is HEU declining. Both civilians also military. So the problem is plutonium, civilian plutonium stockpile. This is a plutonium stockpile in the past. Sorry. This is blue one is a military plutonium military stockpile, and this black one is declining. Is in the nuclear warheads because we dismantle many nuclear warheads. But all this blue one is currently at storage. It has supposed to be this yellow line. This line supposed to be disposed by now, but it has still remain as a storage. The problem is this gray and red one. These are all civilian plutonium coming out of nuclear fuel cycle. And this gray one is, the largest one is Russia, UK, France, and Japan. Only 4 countries. And then now maybe China may be coming into the civilian plutonium stockpile. But it's majority of those plutonium stockpile coming from only a couple of countries. So we are trying to stop this separation of plutonium for civilian uses. We don't need plutonium for civilian nuclear energy. So this is a serious problem. Okay, the next subject I like to discuss is humanitarian consequences of nuclear weapons, which I'm personally also involved. We are trying to develop a case, a plausible case in Northeast Asia, under what conditions nuclear weapons can be used. And we developed 25 cases, later 30, including after we developed 25, Russia invaded Ukraine. So we added 5 cases which Russia will start a nuclear war. Anyway, this is the first year we did develop the 25 cases. And next year, we selected 5 cases to estimate how many people will be unfortunately killed by the nuclear weapons. And we have developed 5 cases. The first one, DPRK, was used in 4 countries and terrorists. And we tried to develop diversity as possible. So the number of nuclear weapons used is, the minimum is 1 bomb by the terrorists. The maximum is 24 nuclear weapons by US and China. And as you know, we have 12,000 nuclear weapons. Only 24 nuclear weapons, only 24, but it's quite significant impact in the region. And this is one example. This is China as a first user because of Taiwan crisis. China has a no first use policy, but after the conventional war is getting worse for China, then they started using nuclear weapons to stop the conventional war. But actually started the nuclear war again from the United States. And this is a simulation we did. This blue one is radioactive clouds. The one important thing is, even if the war between China and they attack also all the bases in South Korea and Japan. The region, I mean, the radioactive clouds much wider area. All Southeast Asia, South Pacific will be covered by radioactive clouds. And then number of deaths, all these 5 cases, minimum one is only 3 nuclear weapons used, still 10,000 people will be killed in one year. And the maximum is 2.6 million people will be killed. And then also long-term impacts of the radiation. This is very difficult to estimate. So we have a huge range, but it's, in this case, 2.6 million people, close to 1 million people will be killed by the nuclear weapons. So our conclusion is that about 25 to 30% of the people will be killed by nuclear weapons in 1 year, even if it was very small nuclear weapons. So these are conclusions from our case. The first one is, of course, the country who used the first use of nuclear weapons, they wanted to end the war. But after that, you never know what's going to happen. That's the problem. And also, this is the second point. Once nuclear weapon use, there's always possibility that will lead to global nuclear war within a week, within the days. And the third point, which is shocking to us, because first nuclear weapons are likely to be not the big one, but tactical intermediate range nuclear weapons targeting not the nuclear weapon state, but the umbrella states like South Korea and Japan, because we have many US bases in Korea and Japan. So they are the most likely the first targets. So I keep telling the Japanese public, you believe that the nuclear umbrella is protecting you, but if the umbrella breaks, we are the first target. That's the problem. Okay, the third subject is Pugwash Conference, which I have been involved in since 1990s. The origin of the Pugwash Conference is, as you know, the famous Russell-Einstein Manifesto in 1955. This was also triggered by the Bikini atomic test, and then Japanese fisherman ship called Lucky Dragon. The passengers are killed by the radioactive clouds, and it became a huge issue. The safety of nuclear weapons has been challenged. And Dr. Rothblatt informed Russell that the hydrogen bomb is so dangerous and a dirty bomb. So Russell actually asked Einstein to develop the statement to ask for the all scientists and all people to abolish nuclear weapons and abolish the war. And the important thing is here, discuss the role of scientists here, and then whether we should choose a death or not, because it means we have to have a peace. And I did this famous quote, it's remember humanity and forget the rest is the famous quote from the Lhasa Manifesto. And they call for scientists to get together to discuss the danger of the nuclear weapons. That led to the first Pugwash conference. The Pugwash is a village in Canada. Sarah Seaton, Mr. Sarah Seaton, Canadian businessman, invited all these scientists from East and West. And this is the first meeting in Pugwash. There are two key concepts, spirit of Pugwash. One is dialogue across divides. Scientists individually can speak without any national background and exchange views based on the scientific evidence and try to find a mutual solution. The second spirit is social responsibility to science, which means scientists are the only one actually who know best the consequences of science. And if you are scientists for nuclear bomb, they have to inform the public for the risk of the nuclear bomb. If you're engineering, you're engineer of the AI or whatever, or drones, they are the one who knows the risk of the technologies. But they are the one who have to inform the public of this risk of the technology and science. Okay, so Dr. Rothblatt and Pugwash won Nobel Peace Prize because of the efforts for nuclear disarmament in 1995. And this is based on the dialogue, communication between Soviet and the United States science work together to inform both policymakers in the United States and Soviet Union the danger of nuclear weapons and to explicitly discuss how to resolve the nuclear arms race. So this is a contribution for Nobel Peace Prize. And finally, I'd like to show the last year, the Japanese Hibakusha organization, Japan Hidaikyo, won the Nobel Peace Prize. So we have now 4 organizations, global organizations, won the Nobel Peace Prize on nuclear weapons, Pugwash, ICAN in 2017, and IPPAW, International Petition for Prevention of Nuclear War, 1985, and Nihon Hidaikyo won 2024. So we are trying to collaborate now from now on for organizations to work together for nuclear disarmament. This is the first event we did on the January 28th regarding the AI and nuclear weapons. This is very scary 1 hour webinar. Dr. Jeffrey Hinton discussed the danger of the AI, which can be applied to nuclear weapons. He is strongly against the use of AI for nuclear weapons. So I think the Pugwash is important, can play an important role. As I'm a member of the Pugwash, I believe it is this is the essential time for us to contribute our scientific knowledge to nuclear disarmament. Thank you very much.
Thank you, Tatsu, for helping us complete this fast, but I find fascinating overview of topics in the area of science and diplomacy. Questions?
Yeah, thank you so much for this presentation, which was very inspiring, a bit terrifying. One of your slides, you mentioned the different scenarios, you have the possibility of nuclear war that would be unintentional, or
Yes.
the usage of nuclear weapons would be unintentional.
Well,
In my naive view, I thought that nuclear weapons are totally protected and that can be triggered only based on the decision of multiple individuals, right? Or is it the case it's already AI that is controlling the weapons? Tell us.
well, we have developed 25 cases.
Yeah.
Roughly half of the cases so-called started by unintentional
How would that work?
well, miscommunication, misunderstanding, those are the things.
Okay, but unintentional, but still, so it might be miscommunication or maybe believing that there is a weapon
That's right.
that is being sent, but still, the decision at some point to make use of the weapon
Yes,
is a human decision.
exactly.
In all your scenarios.
Yeah, all the scenarios, no mechanical,
Yeah,
except the one Russian case. It's a Russia actually developed a technology system that automatically respond.
so I've heard about that.
Yeah.
Is it true? You know?
We heard that, we don't know if it's true or not, but we have information that could be the case. So 25 cases developed by all security experts and nuclear experts. They have to think that may be the case. We have to prepare for the worst case.
Of course.
So whether it's not true or not, I don't know, but could be possible, could be the case. So that's why one case is that.
Thank you very much.
So, when considering that many of these international treaties are now under
Threat.
threat, what is the current status of some of the important?
Well, I think the only nuclear non-proliferation treaty (NPT) is a global forum that both nuclear states and non-nuclear states get together. So I think the NPT is the most important forum, and that's definitely the case. But I'm going to attend the TPLW conference next week. There's another important place that so-called stigmatizing nuclear weapons. And the norm that nuclear weapons should never be used or held should be expanded more widely. So I like to attend that meeting to how they are trying to develop such cases. Finally, the nuclear weapon use, we develop the cases is nuclear weapon will be used under a very high tension of security concern. So I think relaxation of the security environment is the first thing we should do, instead of emphasizing nuclear deterrence. So I think the dialogue, even for nuclear deterrence, they need a dialogue. So you have the communication to prevent the misuse of nuclear weapons. So I think dialogue should be most important part of our mission, and that could be the case for any conflict. But I think it's particularly important for preventing the misuse of nuclear weapons. So that's what we propose.
But are these treaties, are they some of them going to expire?
The new START treaty between US and Russia could be expired in 2026. So I think getting too late. So they have to develop a new one. But I don't explain too much this time, but traditionally the nuclear disarmament treaties try to reduce the number of nuclear weapons. But the number is no longer not necessarily the important. I think quality of nuclear arms is very important. And also the cyber AI, those things should be discussed more seriously. Yes.
Thank you. In this nuclear disarmament agreement or project, is there any use of novel technologies that can reduce the half-life of nuclear waste, such as this project that has been started at CERN a couple of years ago?
Scientifically, yes.
Based centrals that can actually also burn off the nuclear waste to some degree, right? It could last for a few hundred years instead of.
Well, plutonium can last for 12,000 years, so it doesn't cannot be changed. But tritium, for instance, only 12 years half-life. So they have to replace tritium all the time. So I think stopping producing tritium will probably reduce the risk of nuclear weapons. They cannot maintain the nuclear weapons, and the United States and France are producing tritium, for maintaining the current stockpile. So stopping plutonium production for weapons use is one important aspect to reduce the nuclear weapons. Of course, plutonium and high-range uranium should not be produced anymore. So I think stopping the production of fissile materials for future nuclear weapon use is very important. But not changing the half-life is very difficult. I mean, it may take a longer time to develop such technology, I think.
Even if we have a drive for, if we just say that we could change, we could stop producing these weights and go for a much more ecological solution based on thorium and not uranium. Could that be an area that many countries could adopt?
Well, I think one thing is the current stockpile should be reduced, means that either you have to change HEU to a low enriched uranium that they cannot be used for weapons. Plutonium, either you have to dispose underground or use as a field and then dispose. They're the only things that we can do at this moment in the short term. Do you understand what I'm saying?
Yes, but we can take it later.
Okay, sorry.
All right, so we are going
I
for
guess
one.
I don't have a question, but I have a short story that I think is very fitting for this, because I had the pleasure of seeing Joseph Rotblat at ICPP. So we were in the Adriatic, naturally a small room and with a smaller audience than this. It was 1988. That was probably actually the peak of the Soviet Union nuclear arsenal. And he came in with 2 metal cans and a metal funnel. And in one of the metal cans, there were 77,000 little metal bolts. So that was the number of nuclear weapons. And he started his talk pouring 77,000 metal cans into the funnel, into the tin. And it made a lot of noise for 3 minutes. And says each of these is a nuclear explosion. And I think no one in the audience.
Very good.
But the good thing, he got the Nobel Prize, and so I wish all our 4 panelists today to go on. So I think say success.
So let's thank
Thank you very much.
again. We are running fashionably late, but I think that this is okay, given the topic and the discussions. We are going to take a 10 minutes break to enable setting up of the room for the second half of today's event, so the conversation. Before we take this break, I would just like to mention that there is no rule for people under 40 not to ask questions in this particular event. So please come back for the second half and help us with interesting topics. Thank you very much. I think we're ready to start with the second cozier and even more informal part of the day together. So, my job here is both fun and difficult, because I am supposed to help start, but only start, this part of conversation. And then I hope that there will be a lot of interaction with people in the room and with people online, if possible. So we've heard a few quotes throughout the talks, beautiful and inspirational. I also have one that I would like to share and use for the beginning of this. And this is something that I discovered when I was a PhD student in Boston, at the Library of the Capitol in Boston, right? And you go there and there are letters preserved in glass cases. And one starts with, "My dearest Portia." And then, it's description of a stroll in Paris in May 1780, and monuments and arts and museums. And then at some point, the person writing, who was a very interesting future president of the United States, says, yeah, all of this is beautiful, and I could spend hours describing the paintings, the statues, the tapestry. That's not important. I don't have time for that. I must now study politics and war, so that my sons have the liberty to study mathematics and philosophy. And my sons must study mathematics and philosophy, so that their children have an opportunity to start studying poetry, paintings, tapestry, commerce, etc., etc. Now, the person who said that was John Adams, who was the second president of the United States. And I don't know, maybe we can start this by asking ourselves, so which generation are we? We have had the privilege of, thinking about mathematics and philosophy, certainly for most of my life as a lucky person who was born in Italy, went to study in the United States, and then come to work in Switzerland. But where are we?
I think for us, it's the first stage. We are not, okay, it's true that we are dealing with physics, mathematics, biology, chemistry, whatever, but I think we are lacking very important factor of the real role of the scientist. Because a scientist is not meant to stay inside the lab, I'm working with microscope. So I think that we have further importance than just doing experiments. And whenever you have the opportunity to deliver a deeper impact on what this science can do, I think it makes us more, don't want to say useful, because sometimes some people think of some experiments as useless. And I feel this a lot, for example, when I work with experiments on cultural heritage and archaeology. And some people, like engineers or dealing with the basic science, they say that, so you're studying a mummy, and then what's the conclusion after you study this mummy? But for archaeologists, understanding this mummy is something very important because it keeps the traces of our history. I'm Egyptian, and I worked on a mummy that is kept in a museum in Spain. And the team working on this mummy, they were from the UK and Malta. So you see that even working on a mummy that may seem to other people will not solve the problems of the Middle East, but at least you just add small pieces to the huge puzzle. And if you work on diseases, for example, diabetes or Parkinson or Alzheimer, material science, energy, water harvesting, especially in this region where water is scarce. So I think it's good that we are dealing with science and physics and biology, but somehow when you are destined to be in a region that's one of the most boiling points on Earth, I think you should try to twist a bit and try to learn more about how you can effectively provide science, but also aid or assist in understanding more of the political or geopolitical conflicts. Somehow we developed this experience at Sesame, and we are considering all the factors, we are considering the environment, we're considering everything going outside. But now we are more accustomed, I would say, we are ready. And we have our motivation also to stay there. Otherwise, I mean, even if this place is one of the most important particle accelerators, it would be nothing without its people. So I think it starts with the people. It starts with the people.
Thank you, Jihan. Atish.
Yeah, I think we probably belong to this. I mean, I am a physicist, but partly, now I'm in the shoes of Salam in some ways. And I do find him an inspiration, not only in physics, but also about his commitment to global science. And I think it is important that, after all, we are not only scientists, we are citizens and human beings. And I think dedicating some part of your life to these issues is, I believe, is very important. And I think that was what Salam used to say, that you give part of your time for, keep your mornings free for physics, as a director, but then keep some time for some of the issues. And I think this kind of engagement is really important, I believe, in part of scientists, as not only there are much very difficult issues like nuclear security is not something to be ignored and live in.
Or taken for granted.
Taken for granted.
Can I just remind you to keep the voice level a bit high for the people online? Thank you very much.
We have a question online, and
Fantastic.
thanks to the great facilities, I think it will be asked live.
Oh, okay. Please go ahead.
So, good afternoon, everyone. My name is Matteo Gatti, and I work at École Polytechnique in Paris, in France. So, many thanks, first of all, to SECAM and Marvel for organizing this very timely conversation and all speakers for what they do. And I find it interesting to compare the current situation of synchrotrons and HPC facilities in Europe. So, please let me tell you a short story and a couple of related questions. An experimental colleague from the University of Rwanda, let's call her Jane, doesn't have access to experimental facilities in Rwanda. However, she can apply for beam time at a synchrotron in Europe, for example, Elettra in Italy. If her proposal is accepted only on the basis of scientific merit, Jane can carry out the experiment for free, benefiting from the advanced experimental equipment and the expertise available at Elettra. This is great for both Jane and Elettra, which is a facility that truly benefits from exchanges with users. However, there is a practical problem, which can be a huge barrier for her. Jane should still travel to Italy, which may be too expensive for her, and it can be difficult due to issues related to visas. So, a question for Dr. Kamel. What should we do as scientific community in practice to help making these barriers smaller? There is also a second part of the story, so if you allow me, I complete the story with the second question. Jane also has a collaborator at the same University of Rwanda. Let's call him John. John is a computational scientist that simulates the experiment of Jane. Like Jane, John in Rwanda doesn't have access to computational resources. However, having a good internet connection, John could connect to a HPC facility in Europe, for example, Cineca in Italy. John should apply to get computational time at Cineca, as Jane does for beam time at Elettra. The situation at first seems much better for John than for Jane. He doesn't need to travel to Italy, as he can carry out all simulations fully remotely. However, in practice, there is a barrier for John as well. Euro HPC supercomputers are open to scientists located in Europe only. This is bad for John and for Cineca and the community codes that directly benefit from users. Indeed, this rule risks to be short-sighted for the European community itself. Potential non-European users like John will finally start to use and contribute codes developed in collaboration with HPC centers in other areas of the world that are open to them. So, question to Professor Dabulkar. Would you advocate a change in the rules such that Euro HPC supercomputers are accessible to users from low-income countries outside Europe like Rwanda? Thank you very much.
Thank you, Matteo.
Thank you. So thank you, Matteo, for this thoughtful question. I mean, I liked it because I live in somehow at Sesame, and I give you a hint of how do we deal with such I would say issues. So for us, science, as you said, I like it when you said that any scientist like Jane can submit a proposal that is being evaluated just on the scientific merit. This is the practical case at Institute of Facility and other similar institutions as well. So sometimes you're totally right that an excellent proposal is accepted because of scientific merit, but then this proposal, unfortunately, being dropped because of different reasons. And the different reasons are particularly two reasons for us. It's either, or for the users outside, it's either financial support or entry visa issues. For us at Sesame, we are having, unfortunately, Sesame funds only users from its members because the budget is coming from the members. However, we try to solve this issue for non-members. For example, users from Europe, we have European projects with the EU to fund users coming to Sesame. We are having now EU projects, those are having Africa and African scientists in their portfolio. So now we are having 2 EU projects with a scope of Africa to allow the African researchers, since you mentioned a user from Rwanda, I don't know if that was an example or just like the real case, but I would say that for financial issues, you can solve it with partnership or agreements or collaborations. However, visa issues I would say they are the most problematic because you cannot force it. Unfortunately, you cannot force it, and you just have to find a solution. For Sesame, for example, we are having different agreements with Jordan, and Jordan was actually the only member of Sesame that allowed all the other nationalities to use the facility without visa issues. Some nationalities they do not require visa to Jordan. However, others, even if they require, it's a simple visa application and or visa on arrival or whatever. So we're trying to facilitate as much as possible, but sometimes the facilities cannot force the governments to issue visa. And this is very sad. This is very sad. If you get your proposal accepted because it's exceptional, and then you try to find a solution for financial support, and then you're stuck again with political issues. This is really sad. And unfortunately, I don't think that there is a way out without realistic and practical agreements, not only agreements on papers.
Yeah. Thank you, Jihan.
So it's almost a question that might look like it was planted because ICTP actually has been addressing exactly these issues and has the mechanisms to do it. So we have actually a program called the Training and Research in Italian Laboratories, through which Jane can come to, she can apply to ICTP. ICTP has resources in collaboration with Lectra. And ICTP being a UN organization, the Italian government actually is very supportive of the Ministry of Foreign Affairs to making visas relatively easily available, unlike in Jordan. And there are several examples of scientists coming to training and research in Italian laboratories through ICTP. Even though we are a theoretical physics institution, we in this way support exactly the cases of the kind that you're describing. So Jane actually can benefit. We've had several, every year we have several applications for the TRIL program of ICTP. Second is about HPC, and this was exactly my thinking behind this International Consortium for Scientific Computing. That is evident that we need computational resources around the world. And once again, there is actually, we have a partner institute in Kigali in Rwanda. And in fact, in collaboration with Chineka, we are making time available for John. Actually, there is a John. There was a student who was using Chineka for time through ICTP. But our resources are limited. I mean, we can give only so many fellowships through our budget and so much time on Chineka, which is why the idea of the consortium was, I have been pushing for it. And now we have SECAM as our partner, who will make time available to scientists from African countries through their network, in addition to what Chineka is doing, maybe through CSCS. So I think these are very good questions. And ICTP has found a very good mechanism to address them. And we can do with much bigger resources than we currently have at our disposal. And having a consortium is precisely what I'm hoping that will address that issue, that if we get, and we are getting money of that kind from various partners, and I'm hoping for something more substantial to come through.
Thank you, Tish. And, you know, that's also a little bit the thinking behind the initiative that we described before to competitively provide access to time on HPC resources in Europe. I have to say, you know, we are starting with a very small amount of time and as a pilot project, but we hope that through SICAM, ICTP, and Psyche, broader network in our community, we can, you know, have a catalyzing effect on this. And I think maybe just to add an answer with my own thinking here, I'm not representing anyone or anything except for Sara Bonella. But I mean, I think, yes, we should try to apply pressure on policymakers to eliminate some of these obstacles. The rule on access to HPC machines in Europe, for me, is incomprehensible. When you compare it with anywhere else in the world, it's not the same. One issue that we have, is how do we actually organize ourselves as a community so that we are effective in our conversation with policymakers. And here I have two things to say. The first one is a little bit of advertisement. We mentioned the Psyche 2025 conference that will be held here in August, this August. There will be one symposium dedicated precisely to that, how to communicate effectively, how to understand the policy landscape and how to communicate effectively with policymakers. Now, about the second point, then I would be happy to see if there are questions in the room or online. You know, a lot of what happened, for example, with Bagwash, to me, comes from the fact that, you know, you had personalities like Bertrand Russell, like Albert Einstein, and who were recognized as, you know, figures of cultural significance in their times. And science was recognized as a tool that could affect change. So don't you think that nowadays we have one problem more, if you want, which is that it's harder for us, for good reasons, bad reasons, but to count on a reputation or on the fact that the scientific knowledge is perceived as a value. And because sometimes I have this feeling when I am, you know, in schools or in rooms, and I wonder, how do we tackle that? Shouldn't that also be a first priority for scientific diplomacy? Because in order to convince the policymakers, we need to be able to leverage the fact that the public opinion feels that science is a value. And so that's why I was wondering, for example, you know, what kind of experience you have with Bagwash in your initiative, and then perhaps, Oran, tell us a little bit about how you teach scientists to be effective communicators in this day and age.
In the security policy circles, they tend to disregard the scientific advice. Although they ask for advice, but then they don't listen to our advice. I think they need our assistance to identify technical problems, but in terms of policy questions, they disregard our advice. And even if they want, let's say, Nobel Peace Prize or Nobel Physics Prize, whatever, there's a somewhat disrespect for those people who try to now engage in the policy-making process. The government and policymakers tend to say, no, that's not your field. And physicists and natural scientists, engineers are maybe different, but they tend to also believe that the policymakers don't understand the technology and science. So, and they also it is the government responsibility how to use the outcome of the science and technology. It's not our responsibility. So they try to evade their responsibility to be engaged in the policy discussion. The two sides have not interconnected each other very well. Unfortunately, it's divided. Even in academic circles, security community and the scientific community are separated. That has not been changed much. So this pugwash, I think one advantage is we have both natural scientists and also social scientists work together. And that may be more powerful for policymakers if we make a policy recommendations. So I think in the academic field, it's made more difficult to work together, the natural scientists and the social scientists. But if that is more effectively done, that outcome could be more useful for policymakers.
Thank you.
Yeah. So maybe just I don't think I like your question, but I think it's also like depends on where you are on the planet. So I had a chance to spend more than 10 years in East Asia, in Singapore, and then 6 years in North America and then Europe as well. And I can tell you that there is a wide difference, between these different places in terms of science. In Singapore, for instance, this is a place where they're very pragmatic. They truly value science. They truly value education. And then, policymakers will definitely knock at your door and, give you funding to study a particular problem that they have identified. So this is a place where you can still think that, that process works, and that probably explains somehow, kind of progress you have seen in places like South Korea, Singapore, and other places like that. It's also true now, if you look at North America, they used to be way more, open to scientific expertise, and more like in the past, in the US and in Canada, you had, in the administrations, you had a lot of scientists, holding top places and offering scientific advice. This is unfortunately no longer the case. I think the COVID pandemic has really shown the limits of that. At some point, even the public said enough of the scientific advice, and it's definitely a problem. Now, I think in Europe it's a bit more balanced in a sense, but the scientific knowledge is probably not really where it should be in a sense. So policymakers tend to come from certain degrees. And nowadays we know that a lot of the funding goes into the hard sciences and natural sciences. There is I talk about interdisciplinarity, where, we are doing hard sciences. We tend to come up with solutions, and the elite will say, well, so it's always coming from these people. So we are perceived as being snobbish, as always having an answer to the problem, and that is not helping in a sense. So how can we solve that problem? Probably by bridging the gap between different disciplines. We may have to better understand the perception of other disciplines, having degrees that are probably more interdisciplinary. I mean, EPFL it's an engineering school, was mostly about sciences, but it has been growing by adding a college in humanities, for instance, and this is moving in the right direction. Maybe we should do more about this, and in particular in terms of offering degrees and not so specialized. Right? If you come to EPFL for a bachelor's degree, well, it's going to be very specific, and maybe we should consider, and I told Sarah that we have an initiative at the University of Geneva where we are starting a new degree that is half computer science and half in international relations. So we're starting that in September, and that bachelor's degree, you get a hardcore training in computer science and computational science, and you get a very deep, training in international relations, global studies. And once you have that, you can get a master's degree in global studies, or you can get a master's degree in computer science. We hope, that this, this kind of training will provide people that are like more well-rounded, not scared by the sciences, the hardcore sciences, and also like that have a better understanding of some of the societal problems.
Thank you. Anybody before Nicola raises his hand? If not, Nicola, go.
So I was tempted to ask a question that is especially for Roland, but also for all of us in the room, and it was going back to diplomacy, in the sense that diplomacy is one of these fields where it requires a lot of knowledge of political history, geographical history, international law, and somehow I'm sure you've been asked this, but large language models are fantastic aggregators of knowledge. And as we were speaking, just to test myself, I asked ChatGPT, how would you solve the Israel-Palestinian conflict? And I was expecting, some nondescript generic answer, and actually I'm completely taken apart because he has provided the most lucid analysis and set of solutions that I've ever seen. And I won't read it to you all of it, but it goes from acknowledging core issues to a multi-track approach with a political track and economic track, security track, breaking political stalemates, addressing settlement and borders, justice and reconciliation, involving the global south and non-Western mediation. It feels better than almost anything people could put together. And so the question is, positively, we will have super agents that advise us on how to do diplomacy, or the war becomes a war on artificial intelligence, giving advice, because we'll grow up with a generation of advisors that are the ones that at the end do the nitty-gritty of the political treaties that are used to asking questions to ChatGPT rather than sort of making the question. And so I don't know exactly what my question is, but how do you feel about the future of this complex multi-state and multi-agent negotiations?
I was like reflecting and while you were talking, and I think you and I are coming from the same side of science, the art sciences. So the reason why I'm saying that is I have a joint appointment between the Faculty of Science at the University of Geneva and the Global Studies Institute at the University of Geneva. So because of that, I have the chance to sit at the Collège of Professors in these two institutions, and I see two vastly different worlds. I go to the Faculty of Science, and then we have Fields Medal in our section of mathematics that are so excited. They say, now I'm going to get the next theorem by working with AI. Stan Smirnov is a big advocate of that. He truly believes that my old-fashioned way of finding theorems in mathematics is gone. He's just like you, with open ChatGPT and brainstorm and try to do mathematics in a brand new way. So a lot of excitement, and my colleagues in computer science, we are just like that. We feel that there is a lot of potential. Then I go to the other side of campus, and then I see a lot of skepticism, a lot of worry about AI, the potential. I'm not saying one is right, what is wrong. It's just that there is a lot of potential, but there is also a lot of worry, and I don't know. What I don't know is how to bridge the gap between these two worlds. And we are talking about people that are highly educated, trained, but we are looking at these new tools with sometimes fear, sometimes hope. And interestingly, was talking about the challenges of interdisciplinarity, is that there seems to be very opposite views of the potential prospects of AI, for instance. So I don't have an answer, but it's just something that we should probably think, because those models, they will get better, right? Whether we like it or not, right?
Well, that's a question, actually the second question that I had, because they could become better, or they could become by design more biased, because after all, we don't control who are the entities. And so maybe it could be very interesting to prepare a secret set of questions that are asked periodically to see if there is a directed evolution, basically in the answer. Because what I see now seems extremely rational and even-handed. And I would be curious to see in a year, 2 years, 3 years, 4 years from now, not only on this question, but on many other questions, the different, entities that will be producing these capabilities are going to, let them run free, or they are going to engineer them to, appropriate answers.
Yeah, I see where you're going, and maybe just to finish with that, I think a good analogy is with social networks.
Yeah.
Let's go back to 2010, and everybody was so excited. Yeah, it was a great opportunity. Humanity coming together, we could exchange ideas, and now we are 15 years down the road, and we see the other side of that coin, manipulation, fake news, and the influence on a massive scale that tool can have. And it's true that we don't control how these LLMs are being generated, because they are actually being trained by private companies. So they can induce any kind of biases. That's actually a good experiment. Try to think, you have some sort of benchmark set of questions and see how, you're giving me a great research idea.
A good program for
One thing,
Oh, sorry, is it follow-up? That is a follow-up?
yeah,
Then maybe we go there.
one thing on this story is that I think the problem is that it's not just the companies, that's for sure one side of the coin, and the other side is that the people injecting the information. So if there are people who just spend money or even using other AI to inject fake information, and then the AI keeps playing on it. So it's a very difficult thing to know what to trust in this situation.
Well, I'm sorry, I agree with you, but at the same time, we have to realize that our societies have been biased prior to having AI. And so it's hard to blame, those models for being biased, because they are effectively reproducing that. Now, where I agree with you is that if this bias is amplified, then this is a problem. But we also need to acknowledge that in the analog world, we had a lot of biases. Our societies have been full of inequalities, biases. And if you look at scientific research in the social sciences for a long time, it was all about the US and Europe. And then, the rest of the world was completely ignored, and we made inferences based on, where the research money was. That has been a long-standing problem. But I agree with you that can be amplified with, all these tools from AI.
So I think that I'm going to shift slightly the topic. So in all this discussion, I think that no one never talks about leadership in this sense. So I think the world is showing something which is a very typical human trait, that individual people, single people, who in the end have control of lots of situations, right? So they have their own self-awareness is in the end the reason why many things happen. It's always been like that in history. So instead, okay, that's how the world works in general, in my perspective. And then there is science, which has been brilliant because there are independent minds who create work, and maybe they gather together for small collaborations in the big scheme of things, but there are very small number of people who create something successful. So in all this discussion, what I've always wondered is, shouldn't people focus more on trying to, push forward the brilliant, the best minds we have in science for all the fields of the disciplinary, so having all the disciplines together is something that we have to focus on for sure. But why don't we focus on taking people who are leaders in science and put all them together and try to create something like a community in which they are not simply great minds, but there are people who can influence people. I'll give you an example. When Giorgio Parisi in Italy talks, all the newspapers are going to talk about the Nobel Prize, who said, climate change is a thing. Of course, but it's not only Giorgio Parisi who says that, right? So my point is, shouldn't we put all the Nobel Prize winners, is just an example, people who have a leadership, all together and make science work? Because this committee, I think committee just give an idea, it's there in my mind. But shouldn't we put all the much efforts in creating a group of people who are brilliant and they are also leaders, so they can influence people? That's my point. So science shouldn't go in that direction.
Satish, maybe you can start.
Okay, I would like to answer your question on two levels. One is, what can scientists do, which is within our limited abilities to effect a change? And that I think we should do. So one is to make information broadly. I mean, for example, what I described about ICTP, that we want in a climate response, we want engagement from Ghanaian scientists, because they're somebody having a very fancy model in Bay Area or in Bologna is actually completely useless unless there is a community of Ghanaian climate scientists who know how to use it. And it's a question of trust also, that nobody will trust a model coming from Bay Area unless there are people in the country who can evaluate it. So the policymakers would not take it seriously. So for all these reasons, it's very important to make science globally available, and that's the role that we can play. And maybe have a concerted action of eminent scientists trying to influence policy to the extent that we can. So I think this we must do. But I do see that we should not also fool ourselves, in that some of these questions are very difficult political questions. For example, in the case of the nuclear energy and nuclear warfare, fortunately, thanks to the work of many people, and because of the evident danger that people saw exhibited in Japan, people gathered and a regulatory framework came about. IAEA was formed, CTBTO was formed, Nuclear Non-Proliferation Treaty was formed. So some regulatory framework internationally came about. Now, I believe, so that's why I think the science and diplomacy discussion is very useful now. Now we are at a point where AI and quantum computing are not even in the hands of state players. It's in the hands of transnational players who basically don't give a damn to UN treaties. Because I think now Meta and Google and Microsoft have more computing power than Oak Ridge National Laboratories, by an order of magnitude. And this is a very difficult political problem. I don't know. I mean, it's a question of this kind of very global capitalism, completely power is concentrated in the hands of like 5 people. And I don't think scientists can, apart from being good citizens, have a particularly more brilliant solution to this. So even if you ask Giorgio Parisi, I don't think he has a solution to this. I think we should understand where we can influence and where the solution really will come from political action.
Maybe that's why. Yeah, I think it's a very good question. I'm just thinking about the difference between science and scientists. I think we're talking about science, which is value neutral and truth. We're trying to reach the truth. But scientists have its own value. And it could be subjective, is selecting topics, analyzing the issues. And so scientist community is different from the all scientific knowledge. So how you make the scientific knowledge to be politically independent, insulated from the pressure. Same thing can be applied to the scientists also. I think it's important to how can I say it? As I said in my presentation, independence, authority of the scientists is very important. Because if scientists also have to get the income, research money, and if it's influenced by the politicians and the military authorities, those people may go to the military research, and that has to be cut somewhere. And I think that's my point is, people think the science is a kind of absolute truth, or so that everybody can agree. But in any scientific field, scientists often disagree, right? That's the problem of the science. There's always an uncertainty in the science. And then sometimes you have to make a judgment, particularly for in policy advice. The policy is basically the judgment. And even under the uncertain, with much uncertainty, they have to make a policy decisions. And if you are a scientist to ask for policy advice, you are advising as a human being, in addition to being a scientist. That's sometimes be a complicated issue. So my point is how scientists and scientific community can be isolated, not isolated, insulated from the political pressure, from the industry pressure to get the authority. And then much more healthier scientific community could survive. But otherwise, in Japan right now, is the existing, how can I say, the independent research funding is decreasing. And then the government is increasing the military research funding. So the many scientists go for military research funding. That is not a good way of organizing a scientific community. So how can you prepare such kind of thing? It's very important.
Thank you. That's what I'm.
Yeah, so I love your question, and I think we also, like, as much as we are proud of the work we're doing, I think we should know our place. We have a very important place in our societies, but we also need to respect that we are part of an ecosystem. We need policymakers that are expert at doing that. We need, whether we like politics or not, we need that. We need people that are elected, that are talking to their constituents. So it's like our societies will work as long as we all, have our own, we do our own share and we interact. So there is these, interdependencies, right? And there's, that's what we're saying. If we don't get the funding to do our research, then we cannot do our work. And so we need to have some sort of independence, while at the same time doing our work for the benefit of our society. But at the same time, we need to have politics that are informed, working with the scientists. So what we see as not working right now is that you have some sort of, imbalance in some of these relationships. And in some countries, like in the US right now, it's obvious, right? And it's a major problem. But it's different in different countries. But successful society, I don't think it can be led by scientists. There's actually a novel, I was trying to remember the title of that novel. It's a dystopian novel where scientists effectively lead an entire society. And I can tell you that, it's awful, right? And you can see that in some places, hospitals are run by doctors. Oh, they're not managers, right? They run that poorly. And some people will say some universities should not be run by professors, because we're not, good managers as well, possibly. So this is what we need as a good society. We need to have different people with different abilities. I want to go back home. I want to take a train. It's working because you have people that are experts at that. We all depend on one another. So from that perspective of how society should be built, we have our place. It's an important place. I don't know if it's a central place, but it's a very important place. We should remain there.
Yeah, maybe you also want to.
Yeah, maybe. So I just also want to stress on the point of complementarity, that are all scientists, even if they are inspirational and influential, are they qualified enough to do this kind of leadership? I don't think so, because it's not easy purpose, and if you want to have a concrete conclusion, then you have also to build it on science in different field. And I give you also an example from my I would say region or country, because it's somehow like a custom approach. What's applicable in some places is not applicable in others. In my country, I just noticed the last few months, they are having some quick messages as advertisement that go to the TV. And guess what? They are actors and singers and football players. And so this is like 80% of all these who are giving messages to the society. And very rare you see doctors or scientists. So it gives you just, how to say, like an overview. What is the directed mindset that the leadership, the real leadership is taking you to. And I don't think that scientists alone, even if they are given the opportunity, they will be able to do it. And the last thing I would say that if we do something like this, suppose that we do something like this, the output is called recommendations. And from my experience, recommendations, take it or leave it, they are not obligatory. So we can do the whole work, we give our recommendations, and eventually nobody will be doing them. So I think we need to, like, each one has to take care of their own field, or build on our own expertise, and try to be complementing each other, not to make it worse, because it can be worse.
Can I just add one more?
Yeah.
I mean, I think this issue also came up about, I mean, one could look at the current reaction in the US as a kind of, there's also this reaction against elitism, that there is a concept feeling that scientists are talking down to the common people, non-scientists. I think that, or also there is a question of trust in science. I mean, I'm saying that some part of the responsibility lies with the scientific community also. That, for example, it's very common nowadays that a study shows red wine is good for you. Say, what is this study? Who has this study? You know, somebody in some university has done a study with pretty bad statistics with 200 people, and they want to publish this, and it's published. So it's coming from a scientist, but it's really badly done science, and that has certainly led to this loss of prestige of science, that it is not being taken seriously to the extent that it was, let's say, and I think part of the responsibility also lies with us. Secondly, I think some of these questions are really where it's not really a scientific question. So, for example, let's say IPCC report will show you that we need to bring down, there's no argument that we need to bring down the temperature by such and such 1 degree by, we have, I don't know, 400 ppm of carbon dioxide, we need to bring it down to a certain level. All this is true, but however, there is another side to it, is that the energy needs of the country. I mean, if you tell a developing country like India or China, suddenly cut down their energy, the world is actually consuming, I don't know, so many terawatts of energy. If you look at it, actually, there is no realistic alternative given to the fuel, to the carbon. It's all good to say that we want to go carbon neutral. But if you actually dig deeper, what is the alternative to fossil fuel, which will meet the needs of and the ambitions of the countries in Africa and elsewhere, which we want to come to the standard of living of Europe? There is not really a good answer. So it's very easy to say, oh, these politicians are not addressing, taking our advice seriously. But it's because you have only addressed a part of the problem. So I think all these questions are quite complex, and I don't think scientists should have the hubris to say that we can do better.
Thank you very much.
Just
A quick rebuttal.
no, I agree with all your points. Staying on the last two things you said. So when I say we talk about leadership and so about leaders, what I'm talking about is also about good communicators or great communicators. That's really my point. And as you said, scientists are not usually great in this, right? And so what I want to say, respecting diversity, inclusion, and taking in consideration all the things that you said, so economic situation, political situation, of course, those are subtle and complicated things that can happen. And the example that you just mentioned, I see all your points, but I mean, if you balance all these things together, I still think that it's important there are good communicators, great communicators, that take all the good messages of science, they present it to other people. I gave the example of boulders, artists. I mean, those people are not good communicators. When you see them in the TV, I don't think it's a good communicator. I mean, it's just a delicate subject. It's a very, I know it's a silly example, I understand that. I mean, it's not a good communicator. Scientists are not communicators. So the point is that if you take science, which is not that easy to understand, easy to reach, understand all these things, and you try to communicate in a better way, You create a bunch of people who are leaders. I mean, they have the personality first and they have the knowledge behind, and then they can give they can convey in a better way the information which are important for our world. That's something that we should care about. That's my point.
That's the perfect thing now.
Yeah, I have a question. I mean, regarding this leaders and communicators that my colleague has mentioned, and there has been a lot of discussions how the scientific opinion should be transmitted to politicians. But if we have these leaders and great communicators, wouldn't the most elegant way to transmit this to the policymakers be to make these leaders and communicators a part of policymaking? So my question is, for instance, why do scientists not run for the local parliaments? Because in that way, you would have an advocate for science within the policymaking body.
So as a historical curiosity, right, it hasn't always been like that. The first minister for economy in Italy was a geologist. The first minister for research at university in Italy was a mathematician. So in some parts of the world, I don't think that this is true everywhere, but it's Merkel, right, was a simulator originally. So I think it depends also a bit on how you look, but I'm curious to hear this. Are there more questions after this one? Because I mean, I'm loving it, but we are reaching the 1 hour mark for this part of the conversation. So I think if you have something urgent to ask afterwards, and if not, we will close with one final question for the panel.
It is ideal if you think that the politicians are the experts in a particular field, and that would be, is it possible? But I think practically speaking, it's impossible for one person to be knowledgeable for many fields. And one possibility actually done in the United States and Europe is the parliament has a special function, scientific advice function. And they do provide scientific technical advice to the policymakers, to the parliamentarians. Like in the United States, it used to be Office of Technology Assessment. Now it's under the Government Accountability Office. They are asked by the parliamentarians, the congressmen, to answer to those scientific questions. And that has to be, the problem is that has to be also politically dependent. And it could be influenced by the parliamentary politics. So how to make sure that this advisory function could be independent. But I think you're right. The parliamentarians should have technical expertise, because in Japan, for instance, all parliamentarians, if they need a scientific advice, they do not call scientists, they call the government, the bureaucracy, to get the immediate advice. That is not necessarily healthy. So my short answer to your question is, I think the congressman or parliament should have a dedicated advisory function with a technical expertise.
Probably just, I mean, as Sarah said, we have had examples of scientists going into a role in parliament and so on, and usually it always ends up the same way, is that you have to stop, you don't have academic freedom anymore. As soon as you get into the politics, and as soon as you get into the politics is, you're part of a government, there is a line, you have to follow that line. And if you don't follow that line, you just quit the government, or you quit the parliament. So there is this reality. So people that are scientists and willing to go into that, I think either they know what they're getting into, and at some point you will have to lie, or you will have to simplify things. You cannot be a scientist by saying, oh, it's actually complicated. People don't want things that are complicated anymore. They have a practical problem and they would like to have a simple solution. So our way of dealing with problems by having hypotheses and step by step and abiding by evidence and so on, it doesn't work like that into politics. Whether it's good or bad, it's a different story, but it's just different rules of the game. So if you're a scientist and you get into that, you can make that jump, but you know it's probably going to be your death sentence as a scientist, and you will have to accept that there are new rules. And oftentimes people will say, look, you know, he used to say that and now he's saying this. Of course, he's part of a government. He won't be able to say the opposite of what the prime minister is saying or the president is saying. So there is this disconnection between how science works and how policy making works, and they just operate with a completely different set of rules.
We don't have any more comments from our panelists or questions from the audience. I doubt there is somebody online, but maybe.
No, we are all good.
We're all good, very good. So there is, I'm not sure it's a tradition, but it's a habit to close this type of conversations. And I mean, I first saw this on a TV show on the French TV in the 90s, but then it has been reintroduced here by Nicola. And this is the one, we're going to steal one question from a longer questionnaire to get to know you a little bit better from a human being point of view, okay? And so the question is the desert island question, right? If you had to spend your whole life on a desert island and you could only bring one book and one piece of music, what would you bring with you?
That's very difficult.
It's the most, we like to end on a high note here. Voilà, maybe you can start.
Alors, the book, Le Petit Prince, right, Little Prince by Saint-Exupéry. Like, you can read it and read it again and read it again, and you always, have a new story. I read it as a kid, and then when I read it now, it's a completely new, different book. So I guess I would never have enough of it. Music, wow, I'm big into music, so I can give you a playlist on Spotify with 10,000 songs. So if I have to pick one, La Mama Morta by Mariah Carey.
Atish, would you like to go next? We can circle back, huh?
Yeah, maybe. I need to think.
Don't think, that's the whole point. Just be yourself.
Is it if one is allowed to take a musical instrument?
Yes.
I play the violin, so I would take that with me.
Okay.
And what would you play for us?
I would play Indian classical music for you. Okay. Author, I have many favorite authors, I don't know. Probably, I don't know. I will come back.
All right, Jihan.
Well, because I just heard the parliament and these things, I'll take the Egyptian constitution with me, just to read it and maybe I understand before dying. So. But I think it's huge, and whenever I manage to understand many things, I'll take it. I'll take the constitution. And music is very difficult, but I can take the 4 seasons of Vivaldi. That will be just giving me a huge span of life and
emotion. Yes. That's it.
Can I bring the movie?
No, I like that.
Because I love movie.
We need to go there in Mexico. Yes.
My best
If it's a movie based on a book, then
based on the book. No, not necessarily. My best movie I like is the Butch Cassidy and Sundance Kid.
Ah, there you go.
Which one?
Butch
Cassidy and Sundance Kid.
Do you guys know it?
97. Old movie.
Paul Newman and Robert Redford, I strongly recommend it.
I like music I like is Mozart. Any Mozart I like, but particularly piano concert.
So Atish, surprise us with some punk rock. No, we were talking about a book with you because you have the violin.
yeah, ICTB regulations.
No, come on.
No.
Well, I would probably take the Marathi poetry book with me.
Very good, that's fine. Thank you very much. Thank you also for playing. I'm going to walk through this.